Hi everyone. Today the lesson, as you see, will be recorded. Okay, just follow up the instructions I'm giving to you over here. Again, if you have questions, if you don't understand the lesson, you can watch as many as you want to go over this thing here. Also, okay, you know, I am here in the school Monday and Wednesdays to help anytime you want. Okay, our ARC. You know very well how it works. Great. But let's go to our lesson. Which page? Okay, first thing, take your book. You know where's your book. Okay, I don't know which directions for you, the video, probably, whatever. You know where's the book. Pick your book there. Open the book. Which page? 547. Okay? 547. Great. While you are opening the book, pause the video here with the teacher there. Pause the video, and the students will go there, pick the book. Okay, I hope you are in the book, the page I'm talking to you right now. Let's go over our learning goals for our lesson today. Great. We're talking about tangent, okay, the key terms, cotangent, and inverse tangent, okay? And we start to work with the calculator also. Great. Which calculator? The yellow one, which you know is behind me. Oops. Great. You know very well. It's here, behind me. Just go there, one student, to have one calculator here, okay? And I'll show the instructions how to use this calculator also. Let's go to our lesson, okay? Our learning goals, but before our learning goals, let's go to our vocabulary. Great. Then I will zoom out because the vocabulary is the last one here. Okay, the vocabulary today. I know some of you guys are English speakers, you know very well this stuff, but I think it's good for everybody to understand this pattern, even though you're an English speaker. Wheelchair. What is a wheelchair? Wheelchair is a chair mounted on wheels that is used by a person able to walk. Great. That's a wheelchair. Portuguese, cadeira de rodas. Ramp is the same thing in Portuguese. That's easy to figure out. Or in Spanish, I think also so. A ramp is an inclined plane or sloped surface leading from one level to another level. Okay? This is a ramp. We're using a lot this word here today, okay? Deck. Deck, similar to a porch, is an area to sit and relax outdoors. Great. And waterway is a river, canal, or other route for traveling by water. And a barge. Barge is a large, flat boat used to carry goods on rivers and canals. Okay? Probably you see a barge before. Okay? I think in Portuguese this one is the barca. Okay? Very big. It's similar. It's a cognate also. Great. Then let's go back to our page 547. In page 547, how it works. Pause the video, use a calculator, the yellow one, solve those problems here. Okay, pause the video now. Okay, you are back here. Let's go to our answer key. The first one, probably you got a 0.58. Number two, 3.46. Oh, round to the nearest hundred, okay? 0.71 and 4.24. Oops, 24. Let's go our lesson now, okay? Stepness. Consider the right triangles over here as you see. Which page I am right now? 548. Okay, we have 30, 45, and 60 degree. Describe the stepness of a right triangle in terms of its side length. How you notice here, guys, about the angles and how does it change the stepness? Okay, question number two. Compare the stepness of the triangles shown in terms of their given reference angle. Okay? How do you explain this in words? Okay? Pause the video and try to explain in words, not math, just words. Okay, I think everybody's back here. To explain this, the easy way to be sure everybody understands is the stepness of a right triangle is the ratio. What is this? It's a ratio of a vertical side length to the horizontal side length. Vertical divided by horizontal. Okay? That's the ratio to verify the stepness. Great. Remember the stepness you did like up, rise and up. Like remember this in one-step equation, graphing, probably a two-step equation. The slope, rise and run, rise and run. That's the ratio. Okay, the stepness. Number 2. Compare the stepness of the triangle in terms of the given reference angles. Remember the angles I told you before? 30, 45, and 6. What's happened? It's more steep as we rise the angle. Okay? As you notice, it's more steep. Okay? As we increase the angle, the stepness also increase. Nice. Yep. I won't write here. You can write your own words. But here, activity number 1. The maximum incline for a safe wheelchair ramp, remember the words we started, should not exceed a ratio of 1:12. This means that every 1 inch on a unit of vertical rise requires 12 units of horizontal run. The maximum rise for any run is 30 inches. Okay? Let's just keep writing here, reading. Go to the question, page 549 right now. Draw a diagram for the ramp. Easy. Okay? And remember here the directions. My port is 2.5 feet. Okay? And calculate this the surface of the ramp. Okay, 2.5 feet. Remember the ratio 1/12. 1 up, 12. 1 up, 12. If it's too steep, no one we can get it done. Okay? That's the problem. Okay, probably you finished. Probably you got it. The thing is 30 feet by 2.5. Okay, follow this. That's 2.5 times 12. Easy. Okay, and the length, if you calculate it, is 30.1 feet. Okay, that's a length. Let's go next page, number 2. Which page I am right now? 550. Same thing. Stop the video right now and go through the thing, read and solve number 2, number 3. You need like about 5 minutes to 7 minutes to solve this one. Okay, I think everybody's back here with me. Let me explain right now here. Draw a diagram of the ramp, include the measurements for the vertical rise and run. Attention here, to weigh 18 inches up, 18 up, I need to multiply by 12. What is the length? 216. Great. To have the ramp in the proportion given, the ratio given. Okay? As you calculate here, we can go over. B is the same thing. Calculate this, the length of the surface of the ramp is 18 by 8, 216. Compare the two ramps. Are the triangles similar? Compare the ratio. Is the same ratio. 1/12. 1/12 this, 2 and question 1. Yes, same ratio. 1/12. Great. Let's go here. 4 and 5. Pause the video. So 4 and 5. 5 minutes. Great. I think you are all back here. What does the ratio of the rise of the ramp to the run of the ramp represent? Compare and describe the angles of inclination of the two ramps. Okay? First, we are talking about which page we are? Okay, sorry. We're page 550. 550 again. Okay? The ratio represents the slope. The slope. We talk about a lot about this in Algebra 1 and Grade 8 also. Okay? And compare and describe the angles of inclination of the two ramps. The angles of inclination of the two ramps must be equal. Okay? As the ratio is the same, the angle also is the same. Remember the angle-angle similarity? You see here on the right side of my board. You can see the angle-angle similarity. If the ratio is the same, the angles also is the same. Great. Let's go next one, page 551. Let's talk about the new thing, tangent. The tangent of an acute angle is a right triangle is the ratio of the length of the side that is opposite the reference angle to the length of the side that is adjacent to the reference angle. The expression tan A means the tangent of angle A. You can use the tangent of an angle to describe the slope of a line. Great. As you see here, we have the description of tangent. If you are stuck, no problem. 551, we have an workout example. You can read and understand a little bit better. I will leave a link for a video you can watch. It's talking about this also. You can stop my video right now, go Google Classroom. You will see the link for this explanation here, the work example. Okay? Number 6. Use the work example before. Complete the ratio that represents the tangent of angle B. The tangent of angle B is what? Is the distance AC divided by BC. Okay, this angle B here, AC, opposite divided by adjacent. Okay? Now let's talk about the cotangent, okay? Page 552. Okay, 552. The cotangent of an acute angle is a right triangle is the ratio of the length of the side that is adjacent to the reference angle to the length of the side that is opposite the reference angle. The expression cot A means the cotangent of angle A. Guys, tangent and cotangent is like a reciprocal for each other. It's just flip the fraction. Tangent, opposite, adjacent. Cotangent is adjacent, opposite. Okay? That's it, just for help you understand better. And as you see, you can try complete the ratio here of angle A. You will see is adjacent, as I said to you, AC, BC. And showed it algebraically. We can show here. Pause the video. You can try to explain this to me. Great. I hope you try this. This A equals 1 divided by opposite over adjacent. To divide by a fraction, here's a hint. Keep, change, division becomes multiplication, and flip. Adjacent, opposite. And this is the cotangent, which is adjacent divided by opposite, as I said to you. Great. Number 9 is just solve a problem. I give to you the ratios over there. On the same page, 552. Solve for me. Great. Pause the video. Solve for me. Okay, I hope you find it. You will see tangent of angle D, this angle here, is square root of 3 and divided by 3. And cotangent is square root of 3. Oh, cot. That's right, cot. Okay, cot is better. Equals the square root of 3. And DEF, the angle E, this guy here, is the tangent, is square root of 3, and cotangent is the square root of 3 divided by 3. I hope you got it this one. Great. Let's go to page 553. You have used the Pythagorean theorem to solve for unknown side length in right triangles given two of the sides. In this activity, you will explore how you can use the tangent ratio to solve for unknown sides given an angle and the side length. Great. Now, attention here. Let's go the other direction. Let's use the word problems to apply this stuff here. Okay? First one, consider the proposed wheelchair ramp. 4 degrees, 24 inch. What information about the ramp is required to show that the ramp meets the safety rules? What I need to have to the wheelchair works. Okay, this ramp is safety or not. B, write a decimal that represents the greatest value of the slope. And use a technology to calculate the tangent of angle 4. Now is the calculator thing. Okay, I will help you over this stuff. And write a decimal to represent this in calculator. Okay. First of all, the first thing, what is the safety ratio? Okay, I'll pause the video first. Try to solve. Okay, I think you are back. After you solve this thing here, what is the safety ratio? Tell me, this is 1:12. I think I told you we're on page 553, just in case. Okay, 1:12. Write a decimal that represents the greatest value of the slope of the safe ramp. Okay, the greatest value is just divide this calculator, 1 divided by 12, which is 0.083 repeating decimal. Okay? Use a technology to solve the tangent of 4 degrees. Attention here. Let me just find my calculator. Let me just open the calculator here to show to you how to do that. Calculator, where are you? No. Oh, sorry guys, I don't have my calculator here. But no problem. No problem. Let's go back here. I will just show here another one. No way. Okay, now it's back. Okay, I'll just change here. I'll put in my computer, the calculator. It's the same calculator, the yellow one you have in the classroom. Okay, nice. I'll just change here the capture window. Nice. Let me just try to organize here to be sure you can see. Great. I think all you can see my calculator. Nice. I think it's better now. It's not perfect, but I think you are able to see at least. Okay? Nice. How can we do that? First of all, you need to check if your calculator is degree mode. Okay? How do you see? Go here, mode. And you go here, radian. You see radian. You need to change this for degree. That's the first thing. If you keep as radian, you'll have a problem. Okay? Okay, after that, just go back. Just clear. Nice, you are back here. How can I calculate the tangent? Can you see here the symbol sine, cosine, and tangent? What I calculate here? Tangent. How many degrees are I calculating? 4 degrees. Enter. And we got the tangent, which is 0.069999. Nearest hundredth, 0.7. Or 0.07, sorry, my bad. 0.07. Nice. I think you understand how to calculate the calculator, okay? You know how to use. Great. Nice. Be sure about the mode, okay? Why, mister? Let me show to you if you don't change the mode, what's happened. Okay, I keep it rating here as you see. Let's go here, tangent number 4. Tangent number 4. Can you see? Mister, there's no sense. Guys, in classroom I'll explain to you. But I hope you remember what is the difference between radian and degrees. Radian is about how many times I circle, the circumference. That's the radian. Okay, but we talk about this later. Okay, I'll explain to you later this thing. But okay, let's go back here to our presentation. I will not show anymore the calculator. I think you got it. If you don't got it, no worries. We can work together later in classroom. And just organize here to become this beautiful thing. Okay, I think as much as I can do it. Okay, I think it's fine. Now, let's go next. Okay, compute the run of the proposed ramp. Okay, how we do that? In calculator, tangent of 4 degrees equals 24 divided by x. You find this number here, 0.07 equals 24 divided by x. So for x equals 343.22. Okay, that's the way to solve this thing here. Let's go here, next one. This is the same thing, okay? Pause the video, solve those two problems here, 2 and 3. Okay, I think you are back here. The first one, the answer key is 286. The second one is 7. Okay, I'll not show how to do it because suppose you know. If you don't get it, pause the video, try again, different way. Okay. Number 3, if other ramps that have 4 degrees measurement are drawn by extending of shortening the rise and run, will the tangent ratios always be equivalent? The ratio always will be the same? Yes, it will be. How do I know? The other right triangles or ramps would be similar triangle with 4 degrees angle similarity. Okay? Let's go keep going here. B and D. Okay. Generalizing ratio. Oops. Which page am I right now? Oh, 555. Sorry, my bad. 555. On this one here is the same idea. Just go over, but right now I have algebraically solved for this stuff here. Okay, how can I do that? Uh, the tangent ratio we have here. Consider a right triangle with an acute angles of no measures and sides no lengths. Do you think the same relationship are still valid or no? Consider the two triangles shown. Okay, we have here 90 degrees. We have here x degrees. How many degrees is the missing guy here? Okay, I think you try to find this one here is 90 minus x. How do I know? Because I know those two angles here together are 90 degrees. Okay, because add up to be 180, then I have already 90. What is missing to this one? 90 minus x. Okay. First, when one acute angle of triangle has a measure of x degrees, what algebraic expression represents the measure of the second acute angle? We did already, 90 minus x. B, what can you say about the two triangles? They are similar or not? Yes, they are similar. Okay, they are similar. C, what can you say about the two triangles? They are similar, as I said to you. B, let's go see here. When the side opposite the acute angle measure x degrees in the smaller triangle is of the length L1, what algebraic expression represents the length of the side opposite the acute angle measuring x degrees in the larger triangle? Well, if A is the side to be the larger triangle here, A is the ratio of the corresponding sides. The length of the side opposite the acute angle is x degrees. In the second right triangle is represented by the algebraic expression L1. Okay. Let's go next one. Next page, 557. Yeah, 556, my bad. 556. Oh, this page here was before. Okay, 555. Okay. For each triangle, write a tangent expression. Okay, this number 1 here. The tangent expression is L1, side 1 divided by side 2. Okay, opposite divided by adjacent. And the other one was because it's bigger, is a factor A. Tangent A L1, A L2. Great. Great, guys. Okay, I think we finish here now this video. Okay, yes, we finish here, and I'll complete this later with you in classroom. No homework today. We stop. We're supposed to stop this lesson today, page 556. Okay, that's it, guys. Bye bye. Enjoy the rest of your day.